Hello. Today I will be discussing a very fundamental part of calculus, known as the limit. So in order to understand the limit, you would need to know algebra. So without any further ado, let us begin. Okay, so for the purpose of this video, we will use a function f of x, which is x squared. And if I were to ask you what is the value of f of x when x equals 3? And you know the answer. You would just plug in 3 into f of x, and you would get f of 3 equals 3 squared, which is 9. Pretty simple, right? And in order to express all x values and their corresponding f of x values, people have devised a very nice system in an xy coordinate graph. And I will just demonstrate one example of this for f of x. So I have my graph here. This is the x-axis and this is the y-axis. And as you might know, x squared is a parabola. It's a quadratic equation. And I know that the quadratic equation x squared has a graph similar to this. Well, I can do a better job than that. Let me try this again. Okay, so this is much better. So this is f of x. So if I were to say, okay, go to x equals 4, what is the corresponding f of x value? So you would have to chart it out, and you would get 16 for this case. If you were to put it at 1, you would get 1. 0, you get 0, negative 25, you get 625, so on. So using this xy coordinate system, we will be able to track any value of x and their corresponding f of x value. But what about this question? What is the f of x value as x approaches 4? So as x approaches 4 from both sides, what is the f of x value that I get closer and closer to? So as you can see from this graph, it gets closer and closer to 16 until when you're at 4, x equals 4, you get f of x equals 16. So the answer to that question would just be 16. Pretty simple, right? And in order to express this type of notation, we mathematicians have devised in calculus something known as the limit. And no, it does not mean, oh, there's a limit of cars from the US, or a limit of cars that you can buy, or a limit of gold coin packs you can get in Sonic. No, it doesn't mean that. It's just a way of noting that the limit, say for our x approaches 4, what is the f of x value? You would just say, as x approaches 4, what is the f of x value? And in this case, it was 16 for f of x equals x squared. Because when we saw in the graph, if I draw it again, if I were to graph everything again, then when you're at 4, you have this plug here at 16, and as x approaches 4 from both sides, it gets closer and closer to 16. So that's why the limit as x approaches 4 of f of x is 16. But in this case, you can say that, hey, the limit as x approaches 4 of f of x is just f of 4. So in this case, because x squared is continuous at all, f of x is continuous at all x is real, at all real numbers. So that means that you can just plug it in if f of x is continuous. But what about if it's not continuous? So let's just check that out. So let's take the limit as x approaches 0 for g of x. But you don't know what g of x is, so let me just denote that as 1 over x. Okay, so let us try plugging it in. So we would just get 1 over 0. But you know, we cannot divide by 0. You can just take out your calculator and try that out. And when you do that, it says undefined. So that means that we cannot compute the limit at x equals 0. But why is this so? Well, if you do not know the graph of g of x, let us just graph that out for you. And when you graph g of x, you get a weird graph. It sort of doesn't want to go to x equals 0. It doesn't approach x equals 0. It just goes up and up and up. And this is because at x equals 0, let me use a different color, there is an asymptote, which means that this graph never touches the x equals 0 line. This is kind of odd. That means that there's a discontinuity. G of x is continuous at all x, which is real, except x equals 0. So x cannot equal 0 for g of x. That is why we were not able to take the limit. But what about if we wanted to take a one-sided limit? So let me just go to another page. I'll just draw this graph again. So we have our g of x. So what if I wanted to take a limit from this side? When it goes here, it looks continuous until it gets to x equals 0. How would we denote that? Well, because we're going from, say, -20 to -5 to -1 to 0, that means that we are from the negative side. So as x approaches 0 from the negative side, so we have our superscript, a minus sign, of g of x, that means that until we get to 0, what side does it approach? What f of x or g of x value does it approach? And because there's an asymptote, which means that it never touches this, that means that it must be -infinity, or you could just say undefined, because -infinity is not a number, but most people would just say it's -infinity, and that is a valid answer. It approaches an infinite value and in the negative direction, which can only be -infinity. And what about from the other direction? And you guessed it, it would be from the positive side, so it would just be 0 and a plus sign of g of x, and you know this would just be positive infinity. So how come we got two different limits, but we're just trying to find one limit, which is the limit as x approaches 0 of g of x? How come we were able to get these two limits, but we weren't able to find this limit? So this is because the limit as x approaches 0 from the negative side of g of x does not equal the limit as x approaches 0 from the positive side of g of x. The limit as x approaches 0 of g of x does not exist. And this makes sense, right? We weren't able to find a limit. It doesn't exist because in one direction it was going down and in the other direction it was going up. And we never saw a turn in the graph where it just connected or mysteriously connected in some way. So this means that the limit as x approaches 0 of g of x does not exist. But let's see the limit as x approaches 3 of our f of x, or x squared, from the beginning. We know this is 9. But what about the one-sided graphs? What about from the negative side? Well, we can graph our thing again. We can graph it again. And at x equals 3, we get 9, right? So as we're getting closer to 3 from the negative side, we're getting closer to 9. So this means that the limit is 9. And what about from the other side, from the positive side? Yes, we're also getting to closer to 9. And because these are the same thing, this limit exists, and it is whatever the one-sided limits are. So kind of makes sense, right? Okay, so now I hope you have a firm understanding of the idea of the limit. And in the next video, we will try to find other ways to solve equations, like, say, the limit as x approaches 0 for something which would give us, say, 0. So, x squared over x cubed. Well, we cannot really, compute this because it would just give us 0 over 0. But if we were to, simplify this, this would just give us 1 over x. And because we know that 1 over x does not exist at x equals 0, this limit does not exist. Or other types of limits, like, say, the limit as x approaches -2 of x squared plus 4x plus 4 over the x squared plus 5x plus 6. And when you plug this in, you get 0 here. And if you plug it in here, you would get 4 minus 10 plus 6, which is also 0. How would we solve this? So in the next video, we will find out how to solve this type of limit. And indeed, we will solve this exact limit. So hope to see you guys in the next video. I hope you guys enjoyed this and you learned what the idea of the limit was. Thank you for watching, and have a nice day.